Hi, welcome to Mrs. Park's Algebra 1 class. This is Chapter 3, Section 3, Rate of Change and Slope. Okay, so why are we doing this? Alright, here is a daredevil drop at Wet n Wild Emerald Point in Greensboro, North Carolina. It looks like a fun ride. It's a thrilling ride that drops you 76 feet down a steep water chute. The rate of change of the ride describes how far a rider goes over the course of time on the ride. Okay, so how far or how fast it goes over time. Rate of change. A rate of change is a ratio that describes, on average, how much one quantity changes with respect to a change in another quantity. So if you were at this Wet n Wild water park and you're riding this thriller ride, the change of rate is it drops 76 feet down a steep water chute. So how far does it go over time? Okay. Right. For us to calculate that rate of change, you put the change of y over change of x. Okay. The x is the independent variable and y is the dependent variable. Okay. So depending on the x, the y will change. Okay, so always remember this part right here is the y over x. Right. In another example, find rate of change. Entertainment. Use the table to find the rate of change, then explain its meaning. So here's a table. It looks like it's talking about number of computer games and the total cost. So x and y. So x is the dependent variable, y is the x is the independent variable, and y is the dependent. So depending on the number of computer games, the y will change. The cost will change. So if you have 2 computer games, it's $78. 4 computer games, $156. 6 computer games, $234. Okay, so the change in y, the dollars, over the change in x, games. Okay, the change in cost over the number of games. So you can actually do any one of these. In the textbook here, you have 156 minus 78 for the change difference from here to here. Okay, subtract the change from 4 to 2. So if you choose these two, make sure it's the right one for the x as well. You can't do 156 minus 78 and then do 6 minus 2. It has to be the same consistency. So here you have 4 minus 2 at the bottom, and it is simplified to 39. So that means each game cost is $39. Now this would be the same if you do, say, 234 minus 156. If we went this change here over 6 minus 4, that would still give you the same rate, $39 per game. Alright, so here's your turn numbers 1A and 1B about remodeling. Okay, your number of tiles and the area of tiled surface. So find the rate of change and then explain the meaning of the rate of change. So go ahead and pause the video and come back when you're done. Okay, welcome back. Moving on. So far you have seen rates of change that are constant. So it's constant, meaning it's one rate. Okay, so many real-world situations involve rates of change that are not constant. Okay, so when we're talking about constant, it's just one steady. So let's go back here. So for a rate like this, you'll have on a graph, it'll just look like this. That means it's constant. It starts at 0. You don't buy any, then you don't pay anything, right? But here you see a graph that's not just a straight line. It has several stops on it. So the graph shows, it's a graph about an amusement park, the number of people who visited U.S. theme parks in recent years. Find the rate of change for 2000 to 2002 and 2002 to 2004. Okay, so the rate of change for 2000 to 2002. We're talking about this here and this here. So this rate of change right here. Okay, let's choose blue. So right here, that's the change in these 2 years. Okay, so the years would be the independent variable. Okay, so that will go on the bottom. The dependent goes on top, depending on the years that people change. So the years from 2000 to 2002, you take the big number, subtract it from the bottom, and then people change from 324 to, well, it changed from 317 to 324, so we're going to subtract the big number minus the small number, and then here you have 7 over 2, which is 3.5. So what does that mean? Over this 2-year period, attendance increased by 7 million for a rate of change of 3.5 million per year. Okay, so each year was 3.5 million, and another year 3.5 million. Altogether, within the 2 years, it was about 7 million. Okay, now let's do the same for 2002 to 2004. Okay, same graph from 2002 to 2004. So big number minus small number on the bottom and on the top as well. So 325 minus the 324 on the top. Okay, and you have 4 over 2, which is 2. No, I'm sorry, that's 328. 328 minus 324. So again, for this year, you got about 2 million per year, so a total rate of 4 million. Okay. Explain the meaning of the rate of change in each case. So we did that. Okay, and for the first case, 3.5 million people more people went to a theme park each year than last year. And 2002 and 2004, on average, 2 million people more people attended the theme parks each year than the last. How are the rates different of rates of change shown on the graph? There is a greater vertical change for 2000 to 2002. So you see here, this is steep, this graph right here. So there's a lot more people increased here than it did here. Okay, there's only a small increase here, but from 2000 to 2002, it went up a lot. So that was a big increase. So it was steeper. So maybe they had a brand new attraction that brought a lot more people in, so it just went up real fast here. But then people, got used to it and they didn't go as much. Okay. Alright, so here's your turn number 2. So it's the same graph. Without calculating, find a 2-year period that has the least rate of change. Then calculate to verify your answer. So go ahead to number 2 and come back when you're done. Okay, welcome back. Alright, example 3. Constant rates of change. Determine whether each function is linear. Explain. So remember, linear has the word line in it. So it's a straight line. Whereas a graph like this, it's not a straight line. Okay, a straight line is just one point to another. That means it has to be a constant rate of change. So if you figure out each rate from here to here, you added 3. Okay? From here to here, excuse me, you add 3. From here to here, 3. From 10 to here, 3. So that's consistent. What about the y's? From here to here, from -6 to -8, you subtracted 2. From here to here, -2, another -2, and another -2. Okay, so the rates are consistent. So therefore, it is a linear function. Now let's try for here. From here to here, you added 2. Add 2. Add 2, and add 2. So far, so good. Now the y's. Add 2. From here to here, whoa, that's add 4. So that's not right. So this means it's not a linear function. Okay, it has to be consistent, okay, all the way through. If there's something that's not, then it is not a linear function. Okay. So here's your turn 3A and 3B. Go ahead and do exactly what we did for example and come back when you're done. Well, actually, when you're done with this, that is the end of part 1 for this video, and come back next day for part 2. Okay, thanks for watching.